Okay, 5.3, the natural exponential function, e. Okay, the number e here. This is how they calculated it and how we get it. So 2.71 is what we'll use for e. If we're just doing a quick average or whatever we want to do, a calculation. And then we call this continuous compounding interest. So continuously, we call it PERT. So PE to the RT. RT is your exponent. P times the number E to the RT. So you can refer back to this page, beginning of the recording, to remind yourself what each of these things are. P is what you're going to start with, what money you're investing. They call it the principal. Okay. So, and then we have compounding interest formula, where R is your rate and the T is the number of years, and N is how many times a year you're doing it. Okay, so let's get going on this. Use the graph of y equals e to the x. So e is bigger than 1. Okay, so this is increasing. Goes through y equals 0, so it's increasing, and it goes up like this. Okay, there's our graph. Now, what are we doing when we have a negative there? Well, that's inside the function. Okay, so this is going to be this will be reflecting it horizontally. Okay, so it goes this direction. Let's do this in blue. So we'll do A in blue. So it's reflecting it horizontally. And then B we'll do in red. So blue for A, red for B. This is reflecting it vertically. So our parent function, we're going to reflect it vertically. All right. So it's going to go through -1 and go like this. Our parent function has been reflected vertically. If you're not sure, just plot -1 and +1 and you'll see where you're at. It doesn't take long to do that. Okay, now, again, we're going to do the same thing. Let's draw our parent function. So this should be easy after our last couple assignments. This means we're shifting it, let's do it in red, shifting it to the left 4 units. So 1, 2, 3, 4. So it's the same thing, except it's going like this. Don't know where it's crossing the y-axis. We can plug 0 in for x and find out. That'd be 2.71 to the 4th power. All right, now let's do blue for B here. We're going to shift it up 5 units. So remember, on these increasing functions, the asymptote needs to shift up 4 units. So 1, 2, 3, 4. And everything is still the same, though. There's your part B. This is B, this is A, and this is our parent function. Okay. Now, we are depositing $1,000, and we're compounding it continuously, so we need to use the PERT function. Okay, so A is your total amount. What do we get after we're done with all this? So P is what you start with, what you invest. All right, E is 2.71, and R is 5 1/4, or 5.25, and T is 5 years. All right, so you have to do the exponents first. Okay, but don't forget, the rate is not 5.25. That's a percentage, 5.25%. So what we have to do is we have to move the decimal over 2 places to make it a real number to use, 0.0525. So if I said hey, you got an 88% on your test score, that's 0.88, or 88 out of 100. So 88 hundredths. Okay. Okay. So we have our rate as a number we can use. So it's really 1,000 times e to the 0.0525 times 5. So you do that on your calculator, and you get 0.2625. So you raise that to e, or e raised to that. Okay. So e to 0.2625 is 1.30017 ... All right. So multiply that times 1,000, and that just moves your decimal over 3 places. So $1,300.18. So the total amount after 5 years at 5.25% is going to be $1,300. So you got $300 that you didn't do anything for, but it took 5 years to get it. All right, so let's do this a little faster. Now, this is your total amount. What do you have to invest? How much money do you have to invest? P. If you're compounding continuously, the PERT function at 3.4%, so 0.034 for 18 years. Okay, how much do you have to invest to get $100,000 when 18 years is over? Okay, so again, 0.034 times 18, that gives you 0.612. So E raised to that is 1.84411 dot dot dot. Just keep going. So we take 100,000. We're going to divide off that 1.8, whatever it is. That's good enough, and that'll give us P. So those cancel out and give us P. So 100,000 divided by 1.8441159. So we have to invest $54,000 at 3.4%. And in 18 years, we'll have almost doubled our money. That's actually pretty good. So if you can get $54,000 and you can get that interest rate in 18 years, your kids' college somewhat will be paid for. Not all of it, but some of it. All right, so now, continuously again, here's P and A. We do have A, the total amount that we're going to end up with. What it's asking for is what interest rate must we have in order for $1,000 to turn into $4,000 after 20 years. So the interest rate shouldn't be too high because you're going to let this set for 20 years. Okay, so how do we solve this? First, we're going to divide off the 1,000. All right, so that's going to be 4.055 e to the 20r. All right, so how do we get this information? All right, so in order to get e to the 20r, we can change this by taking the natural log of both sides. I know we haven't talked about natural log yet. Natural log is e. Okay, so natural log is a log base e, and if these are the same, we end up with 20r. And so you take the natural log on your calculator of 4.055, and that's 1.39995. Now divide off the 20, and that gives us 0.069975, or we could say 7%. That would be a rough estimate, or pretty close, good estimate, but they'd probably say 6.99%. Okay, so that's the rate that you're going to have to use. All right, so we solve the equations here. Remember, if your bases are the same, then the exponents must be the same if they're equal to each other. So x squared equals 7x minus 12. Going to have a trinomial, so move everything over. So this is x squared minus 7x plus 12 equals 0. So now factor it. X minus 4, x minus 3. So our zeros are 4 and 3. All right, and you could check these and they should work. If one doesn't, then it's extraneous. All right, solving this. Remember, this is the difference. Oh, it's not the difference of squares. This is e times x. Wonder if that's a mistake. Let me check this. This has got to be a mistake. This should be e to the x plus 1, e to the x minus 1. All right, so this is the difference of squares, so it's e to the x squared minus 1 equals 0, or e to the 2x minus 1 equals 0. All right, so e to the 2x equals 1. Add 1 to the right side. Now, how do we solve this? We take the natural log of both sides. All right, so again, the natural log of e is just going to be that exponent. And the natural log of 1 is 0. So x is equal to 0. So I don't think this is correct. Let's move on from here. Okay, so here we can factor out an e to the x. So y equals e to the x. And we have x plus 1 left. So this is 0. We're going to find the zeros. So e to the x and x plus 1. So if x is negative 1, okay, that's one of your zeros. And e to the x, set that equal to 0. How do we solve it? Take the natural log of both sides. So the natural log of e to the x equals the natural log of 0. So you take the natural log of 0, and that doesn't work. There's an error. So the only 0 we have is negative 1. An error because remember, e to the x looks like this. So when you have the natural log of e to the x is actually going to look like this. And notice that no matter what you do, you can't get 0 for x. All right. Okay. Find the zeros of f. All right. So now what do we have here? We can take out of here, let's rewrite this here a little bit. We have an e to the 4x. Let's see, we got x cubed 4. No, let's write it like this. 4x cubed e to the 4x plus 3x squared e to the 4x. So e to the 4x can come out, and an x squared can come out. So we have 4x plus 3 equals 0. So what are our zeros? What makes each of these go to 0? Well, this is the easy one, negative 3/4. And that's an easy one if x is 0. And again, e to the 4x looks like this. When x is 0, you get 1. Okay. But you can't get 0 for y. Is the whole point behind these. Okay, you can't get 0 for y because it doesn't ever touch the asymptote. So this one won't work. So these would be our zeros. Okay, this looks really ugly. You can go ahead and distribute if you want. But what I want to show you is these two are the same. So that's e to the x plus e to the negative x squared, which happens to be the same thing as what's on the bottom here. And you have a minus sign, and you have e to the x minus e to the negative x squared there. All right, so if we separate these, that'll be 1 here. And then on the right side, e to the x minus e to the negative x squared over e to the x plus e to the negative x squared. Okay, so if you had to simplify that further, obviously you would have to get a common denominator here, which is going to take you totally back up to there and go from there. All right, let's move on. Remember, we're just simplifying. All right, growth of children. So the Jenss model is generally regarded as the most accurate formula for predicting the height of preschool children. If y is height in centimeters and x is age in years. Okay, so they give you the actual formula you need. So 1/4, x is between 1/4 and 6, okay? So x is the age, so between, you're quarter of a year old to 6 years old. That's what you're looking for. The growth rate, R, is right here. Growth rate is given by this formula, okay? Find the height and rate of growth of a typical 1-year-old child, okay? The height and rate of growth. So we do both of these. So if we plug in 1, for X right here and do the calculation. That'll give us our height. Okay, and plug 1 in here, and that'll give us our rate. So you got to do all you have to do is substitute 1 and then do the calculation. Okay, so let's go ahead and do the top one here. You got to do these exponents first. So 3.261 minus 0.993 times 1 is 0.993. Okay, so that'll give you, we're going to do the top one here, e to the 2.268. So let's figure out what that is. So e to that value is 9.66. All right, so now 6.39 times 1 is 6.39, and the 79.041. So that's going to be the height. So just add those together. So 79.041 plus 6.39 minus 9.66. So 75.771 centimeters. Okay. All right. So that's the typical height of a 1-year-old child. And let's see here. Let's go with our rate. So again, we have to do the exponent stuff first, which we already did this. All right, so that's 9.66. So you have 6.39 plus 0.993 times the 9.66. All right, so 0.993 times 9.66. So we get 6.39 plus 9.59. And that gives me the rate of 15.982. Okay, that's going on. Minimum wage, you're all interested in minimum wage. So in 1971, the minimum wage was $1.60. Assuming that the rate of inflation is 5% per year, find the equivalent minimum wage in the year 2020. Okay, so again, this is going to be a PERT problem. So actually they use different letters for this, but it's the same thing. We're starting at $1.60, and we're going to raise it to the rate 0.05, and the years would be 49. 2020 minus 1971 is 49 years. Okay, so now you do your calculation, 0.05 times 49 years, and e to that value is going to be 11.588 times 160. That's where we started. So we have the equivalent minimum wage is 18.54. All right, so obviously we're off. If we were to continuously start with that minimum wage and move forward.